All right, 3 and 4 here. It says in a right triangle, theta is an acute angle. Find the value of the 5 remaining trigonometric functions. So we're basically given one trig function, like in this case sine, in this case secant, and we're asked to find the other trig functions. Okay, so let me get our handy dandy guide here. All right, so I'm actually going to start with number 4 just because it's a little bit easier, and you'll see why in a little bit. But so secant, remember that secant is hypotenuse over adjacent. So when they give us a trig ratio, they're actually giving us two sides of a right triangle, right? They're giving us hypotenuse in this case and adjacent. Okay, so what I can do is, and actually let me just color code this a little bit. What I can do is I can actually build myself a right triangle. Okay, so I can say, okay, we have this right triangle, and you can orient it however you want. You can, here I have it kind of pointing to the right. You could have it pointing to the left, however you want. And then it says theta is an acute angle, so I could put theta here, or I can put theta here. Okay, so either way is fine. And then the hypotenuse is across from the right angle, so here's the hypotenuse, right? And we know that that equals 5. And then adjacent is right next to the right angle, right? It's the side that's right next to, or the leg that's right next to the right, or the the adjacent leg is the leg that's right next to theta, right? Is what I'm trying to say here. So this is adjacent, and that equals 4, right? Okay. So now what we don't know is we don't know the one that is opposite theta, the leg that's opposite theta, known as opposite. Okay. So what we're going to do is we're going to find opposite, and then we'll be able to find all these 6 trig functions, right? We can already find a few, the ones that deal with hypotenuse and adjacent, like cosine and secant, but we'll find opposite, and then we'll know everything about that triangle, right? We can find all 6 trig functions. So we know I'm going to let opposite be a, so it'll be a squared plus, I'll use this as b, so 4 squared equals hypotenuse squared. Okay, and so now a squared plus 16 equals 25. Then we're going to subtract 16 from both sides. So we get a squared equals 9. Then we take the square root of a squared, and we get 3. Okay, so opposite equals 3. All right, so now we have everything we need to find the 6 trig functions, or the other 5, right? We already have secant, so we don't have to relist that. But let's find the other one. So sine theta is opposite over hypotenuse, so 3 over 5. Okay, cosine is adjacent over hypotenuse, so 4 over 5. Tangent is opposite over adjacent, so 3 over 4. Cosecant is the reciprocal of sine, or hypotenuse over opposite. We already know secant, right? And then cotangent is adjacent over opposite, so it'll be 4 over 3. All right, and so those are the other 5 trig functions. All right, now number 3, same idea, but this time we have a radical in the mix. Makes it look a little more intimidating maybe, but same idea, right? We're going to make ourselves a triangle, and you can orient it however you want. I like to be consistent, so I usually orient it that way, but you can do it, once again, however you want. Now a sine, remember, sine is opposite over hypotenuse, so they're giving us opposite. Okay, so that is the one across right here, so the 2 root 10 All right, and then they also give us hypotenuse, right? That's what the denominator sign is. So the hypotenuse is across in the right angle. And so that's 7. All right, so now let's find adjacent. So adjacent is the leg that's next to the reference angle. And so we'll let that be A, or you can let it be B if you want. Let's make it B. So we'll do opposite, which is 2 root 10 squared, A squared, plus B squared, we don't know what that is, equals C squared. Okay, so now when I square 2 root 10, I square the 2, and that becomes 4. And then I square the square root, and that becomes 10. Okay, so it's 4 times 10, which is 40, plus B squared equals 7 squared, which is 49. So then I'm going to subtract 40 from both sides. So we get B squared equals 9. Then we take the square root, and we get B equals 3. Okay, so 3 is the adjacent leg. All right, so now I have everything I need to find the trig functions. So I already have sine, right? So now I'm going to find cosine. So cosine is adjacent over hypotenuse, so 3 over 7. Tangent is opposite over adjacent, so it's going to be 2 root 10 over 3. All right, and then next we're going to find the reciprocal function. So cosecant is the reciprocal of sine, or you can think of it as hypotenuse over opposite. So 7, and actually let me do this, I'll leave it here, but let me do the work over here. So it's going to be cosecant is 7 over 2 root 10. So I need to rationalize the denominator, right? Now, I do have a 2 root 10 in the bottom, but I don't need to multiply by the 2, just the root 10, right? The 2 is already already rational. And so I don't have to change that. So what I'm going to do is I'm going to multiply 7 times root 10 on top. Then on the bottom, I have 2 times root 10 times root 10. So root 10 times itself will just be 10, right? So it'll really just turn into 2 times 10, which is 20. All right, and then we can't reduce from there. So it's going to be 7 root 10 over 20. All right, now for secant. That's going to be the reciprocal of cosine, or hypotenuse over adjacent. So it'll be 7 over 3. And then for cotangent, right, we're going to have to flip that over, or you can think of it as adjacent over opposite. And so we'll have to do a little math here. So for cotangent, it's going to be adjacent over opposite. Okay, so then we'll have to multiply by root 10. And so we'll get 3 root 10 on top. And then 2 root 10 times root 10 is going to be 2 times 10, which is 20. So this will be 3 root 10 over 20. All right. So that's how, if we're given a trig function, we can find all the other trig functions, right? Because if they're giving us a trig function, they're essentially giving us 2 sides of a right triangle, and we can construct our own right triangle and then solve for the missing side, and we can find everything we need. Okay. And one thing, notice how my triangles aren't necessarily drawn to scale, right? So don't worry about that. We're just kind of using it as a visual to then just try to figure out, okay, where is everything, what's opposite, adjacent, hypotenuse, and then we can kind of go from there. Okay, so your triangles don't have to be perfect or drawn to scale.